Hello everybody, welcome to our presentation on autonomous manufacturing brought to you by our team leader Brett Langland, Henry Jason, myself Maxwell Battist, and Eddie McDougall. So we're going to be talking about the different industries that autonomous manufacturing lends itself to and kind of its practical uses within the world of manufacturing. So we got robot arms showing off some of the more automated work cells in the picture in the background, and then we have a couple companies who are all involved with autonomous equipment in one form or another on the title slide here. So a little bit of background on autonomous manufacturing. It's defined as self-governing, so that means it's going to have little to no human intervention. In an ideal world, the manufacturing equipment would essentially run the whole process by itself. Obviously, there's a huge amount of variability on what determines if a system is able to be self-sufficient, and there's obviously maintenance that needs to take place for machines, but in an ideal setting, autonomous manufacturing would be pure machines with no human intervention. And really where this idea came from was Henry Ford and the birth of the modern day assembly line. So there's assembly lines before Henry Ford, but he really brought together the concept of streamlining work through a series of processes. And that's what the kind of thing you see in autonomous manufacturing is the flow of work from one machine to another. And these machines are highly specialized to perform singular tasks usually. And so it really came about from different technological developments in the automotive sector, and especially during wartime activities when people needed to ramp up production. So you'd see more specialized machines, and as these machines got more specialized and more powerful with modern technology, people were able to implement PLCs and different automated systems that allowed these machines to operate without a human operator. These machines really strive in a setting where a single part is being made for mass production. You don't want to deviate too much with these machines because you're going to lose out on a lot of remakeability of the parts. You're going to need some level of human intervention, whether it be coding in a matrix or just overseeing the production process. With a single product, you can really create a more centralized and efficient process, which you can lay out with these machines. And so you need some basic technologies to perform these: vision and connectivity between your work cells. If you're going to have machines creating these parts, they need to be talking to each other, saying, hey, this part's ready to be picked up, or this part's ready to be moved on to the next process. And then there's also various environmental benefits, whether it be more efficient machines or just reduction of scrap. These machines are typically more scrap friendly because they make less errors. The obvious argument that robots do exactly what humans tell them to do. They don't deviate. You might get some variability from operator to operator, but if you're keeping everything on the same machine, you'll be able to create these parts more consistently.
So now we're moving more onto the timeline of how autonomous manufacturing has evolved into the current role that it has in the market today. And as Max previously said, this kind of all started with Henry Ford's assembly line. Now, there wasn't actually too much that was autonomous in this process, but it kind of sparked the idea of using machines and the technology to increase the speed and production of a manufacturing process. And this was the status quo for a while until PLCs became more popular in the industry, PLCs being programmable logic controllers. And these are essentially just computers that kind of gave basic commands to different machines. And these are quite simple, usually just to control the speed of an assembly line or a crane or something of that matter. But as technology developed, we moved on to seeing robotics being introduced into manufacturing. These simple robots didn't really do much, and again, they kind of had basic tasks, but these kind of evolved and became a large part of modern manufacturing. And as we move closer to today, up to 2003, we kind of see the introduction of autonomous vehicles and different forklifts in that matter. This really shows a lot of new technology being introduced, including different vision sensors, navigation systems, and a lot of advanced programming to ensure that these vehicles are safe and won't disturb or interact with any humans. And this led to a massive increase in the application of technology in autonomous manufacturing. So as we continue to move forward in time, we see that PLCs actually gain the ability to kind of intercommunicate or to talk to each other through different steps along the process. This allows for several steps to be done autonomously rather than just an individual step being done autonomously, which will increase the speed of the process along the way. And as the PLCs kind of learn to work together, we also see that the robots and humans also kind of adapt to work together through collaborative robots. And this is basically robots that have the precision and the safety to work side by side with humans, which allows for more oversight and easier controls of the process. And eventually we see that more in modern times that the humans aren't even needed. We begin to use AI to teach the robots and to have the robots learn for themselves the process that they go through to learn and to carry out the required process. So they're becoming kind of fully autonomous without the intervention of humans at all.
So as Eddie was describing, as we move through the timeline, we start to see some trends develop. So it really became about once the assembly line process was revolutionized by Henry Ford and people realized the power of completing single tasks and sending it along the process, we were able to create more efficient machines to complete said processes, and then they were eventually able to start automating those machines through the uses of electronics and computer components. And eventually in the present day, we're at Industry 4.0, which is kind of the Internet of Things and highly connected work cells. So this is kind of the end goal of autonomous manufacturing, is having a system of machines that are able to talk to each other and send products along the manufacturing process without the intervention of humans. And we are eventually arriving at Industry 4.0 now that we have the technology to actually sustain it.
So now we're kind of getting into what it actually takes to automate a production process up to the modern standard. And one of the biggest hurdles to doing this is the cost of it. This is, well, primarily going to take up a lot of floor space. Pretty much you're going to have to replace the entire old system in order to have a autonomous process instead. But also the cost of the equipment itself is going to be very large, as you need multiple sensors, computers, not even to mention the machines themselves that carry out the processes. So this is going to be a very expensive venture. So to counteract this, usually this is kind of a gradual process, a piece by piece replacement from the old non-autonomous to a autonomous manufacturing process. So this will often result in a kind of a mix of autonomous at parts and being non-autonomous at other parts. And as this kind of new autonomous manufacturing process is introduced, the overall cost per unit will hopefully go down, but the upfront cost will increase, which leads into the next slide about economies of scale and scope.
The economies for scale principle for autonomous manufacturing is especially prevalent because, as Eddie was saying, these machines are huge upfront costs, and typically they're only going to be specialized to one product. So you're going to really want to make as much of the product as possible, and autonomous manufacturing is able to run 24/7. You're really going to be able to pump out a lot of product. You're not going to see a bunch of variability within your product, so economies for scope is followed a little bit less by this principle. Overall, you can't get high variability from the autonomous manufacturing process while pumping out a huge number of products, as you either need the world's best interconnected pieces of machine, or you're going to need some human intervention to make sure that inspection is being done within the process for every niche product. So ultimately, it's just going to be better to focus on a single product, and that's where economies of scale really comes into play for autonomous manufacturing.
First off, we have the Proteus as well as the Cardinal robot created by Amazon Robotics. The Proteus is a remarkable creation designed to autonomously navigate and move carts within a warehouse environment. Imagine a bustling warehouse where all goods need to be transported swiftly and efficiently. Proteus steps in as a fully autonomous solution. Implemented by Amazon in 2022, it is a revolutionary way we handle logistics, ensuring seamless movement of goods with minimal human intervention. Now, for Cardinal, it's another invention from Amazon Robotics. Cardinal is an autonomous robot arm equipped with advanced capabilities. One of its most impressive features is its ability to recognize and pick up specific packages with precision and efficiency. This means faster fulfillment processes and improved accuracy in handling packages, ultimately enhancing the overall efficiency of Amazon's operations. A little bit more in depth on the Proteus robot. This system is equipped with built-in safety perception, ensuring that a secure working environment while maintaining efficiency. This means fewer accidents and smoother operations. What's more, the system enables quick turnover immediately after a product orders, enhancing productivity and customer satisfaction. And finally, while initially designed for product shipping, its applications span across the entire manufacturing industry, from assembly lines to inventory management. This technology revolutionizes various products across the industry. And finally, we have the robotic forklift. This specific AGV is in Bridgestone, Australia. These AGVs significantly enhance efficiency by operating continuously without the need for brakes, thus maximizing productivity throughout the day. Secondly, their precision is unmatched. These vehicles follow precise routes, minimizing handling errors and reducing the risk of damage to goods, ensuring optimal accuracy in material handling. As well, safety is paramount in any operational setting, which is why this AGV is equipped with advanced sensors, enabling it to detect obstacles and swiftly maneuver around them, effectively reducing collision risks and ensuring a safer work environment. Moreover, the flexibility of these robot forklifts is remarkable. They can easily be reprogrammed to adapt to various tasks, catering to the needs of the changing needs of the warehouse or production facility seamlessly. And last but not least, it's very cost effective. While the initial investment may seem significant, the long-term savings are substantial. Increased efficiency leads to reduced labor costs and higher overall productivity.
Now that we've discussed the application of automated manufacturing products, let's talk about the pros and cons. So starting out with the pros, automating manufacturing processes tends to reduce the labor cost and just operational cost. It will have a higher upfront cost typically due to the expenses regarding the equipment as well as maintenance. However, it is typically cheaper over the long run than paying for things like retraining and benefits. Robots can work fairly continuously with minimal downtime, which allows for a higher rate of production, which thus increases the efficiency as well as product quality and reproducibility. Moving over to the cons. So some of the cons, like we discussed before, are a high entry cost. Technology is expensive, especially new technology. There are security risks because robots are automatic, they run on computers, and technology can unfortunately be manipulated. Finally, a quick recap for everybody that either got distracted during the advertisement or had to take a bathroom break or union smoke break. Autonomous manufacturing originally stemmed from the assembly line concept and has evolved very quickly and exponentially alongside technological advancements. It is widely used today by industry leaders such as Amazon Robotics, as well as newer startups that are designing things like automated forklift systems and part transit systems. And it enables rapid production and handling of large volumes of unique goods. The integration of AI as well is driving significant advancements and enhancements in the capabilities of these autonomous systems, and then this innovation paves the way for even greater efficiency and productivity in the future for manufacturing processes. In summary, autonomous manufacturing continues to transform the industry, leveraging technology to streamline operations and meet the demands of modern production and consumption. All right, before we get to the questions, our group would just like to say thank you for taking the time to watch our presentation. We are extra thankful for watching the advertisement. You know, we have to pay the bills, and that watch time is very, very crucial. But yeah, like we said, thank you guys so much, and feel free to ask any questions you may have.